Okay, good afternoon, everyone. We have most of the class here. Hopefully, you can hear me. This is going to be the new normal for the rest of the semester, so we're going to make it work the best we can. Thank you all for your patience, and we will still impart the knowledge of how to program in Python to you. Um, there are a number of things I wanted to go over today that are administrative as well as talking about the actual technical content. Um, you are going to, during the semester, learn a lot about tools and how to deal with them in getting your education. Not particularly the way we wanted to do this, but it's the way it worked. Welcome to Cisco's WebEx. I like this a whole lot better than Blackboard, or I should say I dislike Blackboard a whole lot more than I dislike this. So for now, we're going to use this. If I find a better solution, we may change, but for now, this is what we've got. In terms of the rest of the things that we need to talk about, homework 5 is nominally still due tonight. I understand they're having some problems with gl.umbc.edu. It has been up and down all day. With few people on campus to do the actual hardware booting and rebooting and what have you, that may be an issue. Do your best to submit homework 5 by midnight tonight, please, if you can. If you just can't because gl.umbc.edu is not up, that will be fine. We'll give you extra time. It's not going to cost you for that. I will talk a little bit about the content of homework 5 a little bit later on this afternoon. I'll answer any questions you have. Project 1 was made available the beginning of spring break. The project assignment is out along with 4 data files for you to use. This is a modification of one that was given a couple of years ago by Dr. Mitchell when she taught this class. I kind of liked it. It's a fairly straightforward illustration of how to do functions and how to read from and write to files. The actual meat of the program in terms of the computation, there's really not going to be anything new. It's calculating some statistics about some data you read in. So all of the programming meat for Project 1 is reading in the data files. Remember, you read them in as strings, and then you have to split them up into various components and convert numbers to integers so you can do math on them. And then you print the results out to a file. It's a bit daunting because of the number of functions in it, and I get that. So Lab 6 tomorrow is designed to give you some practice with that, but it should be fairly straightforward, and we'll get you through that. The schedule for the next couple of weeks is going to look like this, and I've taken us through April 8th, which is still scheduled to be the date for exam 2. So tonight we're going to talk about program design, structuring, modularity. On Wednesday, I'm going to spend some time on lists, list slicing, and also multi-dimensional 2D and 3D lists. These you can map to, you can think about as 2D arrays, 3D arrays. They're lists of lists. Up until now, we've always talked about lists being a single dimensional thing. And so in Project 1 and in the homework, et cetera, we've had, you put all the names into one list and all the numbers into another list and all the other things. On Wednesday, we'll talk about doing a single data structure for all of that. Anything loose that we have on lists, and also the topic of mutability, mutable variables, which is a fun one, is going to be next Monday, the 30th. Catch up on anything we need to on April the 1st. And if we have time, we'll also talk about dictionaries, although dictionaries will likely not be on exam 2. We'll wait for the final for those. We'll dedicate Monday, April 6th to a review for the exam, and you will take your exam during class period on Wednesday, April 8th. Obviously, this is in a sense, take-home, open book, open notes exam. I've structured it that way. How April 8th will work is we will all meet here, and I will release the exam to you at 4 o'clock on Wednesday, April the 8th, and you will have 90 minutes to submit it to me. As I said, it's just going to be a standard open book, open notes, what have you. I understand you can Google. I understand you might have several computers. I understand you might have a friend in the room with you that I don't know about. That's all fine. We can deal with that. We were going to start recursion according to the schedule before exam 2. That is also with dictionaries going to be afterward. Now, let's see if anybody has any questions. Okay. If anybody has any questions, feel free to ask them at any time. I've been very happy with the first half of the semester. I got lots more questions, lots more discussion than I got last semester with the majors class of 95 people in Meyerhoff 030. So I understand this is not elegant, but I hope we can continue that. With that covered, the next thing I want to talk about is how we're going to do labs and what your assignment is. Immediately after this class is over, I will post 2 files to the class GitHub site. You can start working on it whenever you want. If you're done homework and you want to knock out the lab in a few minutes, you can do that. You have until Thursday at midnight to finish your lab. You should have seen, if you have not let me know, an invite to use another tool called Discord. Discord is actually a collaboration and interoperability site for video game players. Its target demographic is gamers. But all of the CompSci 201 TAs will now be doing their office hours on Discord. And so for those of you in section 41, Anna will be available on Discord from 11:30 to 12:20 tomorrow. Jordan will be there from 4 to 4:50. So you can check in with them directly if you have questions or don't want to start working on it until they can give you some more information. However you want to do it, office hours are there. You will connect to Discord for office hours. And again, you will submit it on GL, presuming it's up, before midnight on Thursday. And what I want to do now, if I can figure out how to share this properly, is talk to you about what the lab is going to be. As I said, it's mostly a way to look at functions. So if we can get this working properly, all right, here we go. This is the assignment. Basically, I have written a Python program for you, modification one Dr. Johnson did, giving credit where credit is due. What it does is it contains 3 functions and a main program. The main program, and I haven't figured out how to share that because this thing WebEx won't let me open it right now, but if I can, I'll get that for you. I was hoping to show it to you directly. Let me try one more time. Nope, appears it's not going to be let me do that. I'll figure out how I'm going to have to improve my WebEx skills and sharing files. At any rate, I've written a file that contains the skeletons of 3 functions and a main program. And all you have to do is finish the code. As with most of our labs, the beginning of the lab assignment will talk about scope, when variables can be seen, when they can't be seen. Similar to the last Wednesday lecture, there's more detail, more info on functions, how you structure it. This is the core. You will download the file called lab.py. It says location specified by your TA. It'll be on GitHub. You will move that to gl.umbc.edu. You can download it in SCP, secure copy it. We talked about that. If you have any questions, you can ask your TA or ask me later on. And convert that file to names.py. The first thing you will then do is complete the file header comment. I have a skeleton of a file header comment at the beginning of my file, and you'll just replace the date with the day you do it. You'll replace the name with your name. You'll replace the description holder with the description. Okay. I've given you the header and the function code for a function called SumAList. I've given you the function comment and the header, the definition for a function called get string lengths, and similar for one called get names. You will be asked to fill in the bodies of those functions, and the first two are probably only 4 to 6 lines of code, and get names is probably 8 to 10 lines of code. So that's fairly simple. And then in the main program, you'll be asked, you're given some startup code, some initialization, and then you're asked to write the code that does a function call and prints it out. So it's a very straightforward lab, but I hope it will give you some more practice in understanding what a function looks like, how everything is set up, and how this goes. You will submit it. Like I said, it's in downloading the file will be on GitHub. That's all straightforward. Completing it, you will submit it to GL. You'll have till midnight on Thursday. And that's pretty much it for Lab 4, for Lab 6, rather. Okay. So I've bombarded you with a lot of information right now. And before we go any further, I want to ask, does anybody have any questions? I think you should be able to speak. If you can't, you can type them into the chat window, and I will respond to them there. Is everybody good? Everybody wants me to keep going? Okay, I take silence as concurrence, so I'm going to keep going. The topic today is not really all that directly technical, but it's something to emphasize what we've been doing and what we're going to be doing with the homeworks and the projects. And the goal is to design a program properly. Obviously, anytime you write a program, anytime you write software, you want to get it correct. You want to make sure it does what it's supposed to do and it doesn't do anything else. When I say it doesn't do anything else, unpleasant side effects are a thing that can happen with software. We talked about how opening a file for write deletes any previous content, so accidentally deleting your data files is a bad thing. It can happen, right? Your program can be correct, but you accidentally deleted your data files so that nobody else can ever do anything with them, and you don't have them for later reference. We'd like to stay away from that if we can. So get your program right. It does what it's supposed to do, doesn't do anything else. That's the first thing. But for long term, we want to make the program understandable by you and by others. In the long term, people have to read your code. People have to use your code. We hope that you will have a tool you'll be able to use for years, and maybe other people will be able to use your tool for years. This gets back to something I said in the first class, which is slinging code. Slinging code means I write something real quick that I can use to solve a problem today. I never need to use it again. Who cares? This is not that. Designing programs properly is not for that. It's for doing things that I'm going to use in a few years, that you're going to use in a few years, that somebody else is going to have to do something with. Those people who have to review it, your TAs who have to grade it, and people who have to support it later on. Imagine writing a program today, you're doing an internship for your chemistry professor, you write a program that does something for them. 2 years from now, you graduated, you're gone, some other poor intern has to pick up your code and look at it and go, what the heck was he thinking about it? What was she doing here? So you want to make it so that that next intern can come along, pick up your code and go, I know exactly what she was doing here. This is well written. Now I'll fix it. In general, as you've discovered, CMSC 201 teachers are harsh. We try to force you to write code properly. We want you to write code that's modular. We want you to write code that's well documented. We want you to use well understood features. Don't use things in Python that exist, but I'm going to have to read about 97 different help pages and Stack Overflow and a bunch of other things to try to figure out what it does. Use the well understood features that everybody can grok and know what they do. We want your code to be tested. That's the thing we hammer into you. Test as you go. Write a function, test it. Write a function, test it. Don't wait until you finish the whole program to start testing. Test that sucker as soon as you got it done. And of course, your code is evaluated. That is, it's graded because that way we can give you feedback on whether you've done it or not. we don't get any pleasure out of taking points off. We, just want to make sure that you get it right. So you have to design your code properly because professors like us are harsh. Okay, I threw around the term modular. What does that mean? Modular code allows parts to be removed and replaced without disturbing other parts of the program. It kind of helps if you think of your code as a giant Jenga game, right? I want to pull this one out, but instead of just pure Jenga and I just pull it out, I maybe want to put another one in its place. So I'm going to pull this log out, but instead of just leaving a gap there, I'm going to replace that log with another log that might not be the same size, but I hope I've built this program well enough that the whole thing doesn't come crashing down. That's the general idea. Your code's a giant Jenga game. What should be a module? A module should be a portion of code that does an independent task. It just does something by itself, possibly with subfunctions. If you've got something that's independent, make it a function. Then you can swap out that function, put in a new one, change the contents of the function, and when you do that, you have little or no changes to the rest of your project. So in project 1, I have you read in some data that I've stored in CSV files. I talked about this a little bit before the break. CSV stands for comma separated value. Now, CSV files are everywhere. They can be read in by Excel. They can be read in by Google Sheets, any other spreadsheet program. So you run into them a lot. So I have you read in CSV files. But if your code for project 1 is sufficiently modular, and I told you, no, I've changed my mind, you're not going to read in CSV files. You're going to read in straight plain text files. The data values are separated by tabs. Okay, the data in project 1 has a student name and then scores for program, a student ID, and then programs for scores for programs and scores for tests. So instead of a CSV, I'm going to say now the new data files are just separated by tabs on a line. You should be able to only change the function that actually reads in the data and convert and takes it as a string and converts it. That should be the only part of your program you touch. There should be nothing else done to your program because you've properly modularized it. You've properly put the reading in and making it a string in a specific place. So that's the part of modularity that we're talking about here. We've got an independent function, read in the data and give me back a big honking string that I can split. Okay? It just does things on its own. That's a function, that's a module, and that's what we mean by doing things modularly. So modular code, we have functions, they're independent parts, they're things that we can just do by something without touching anything else. The metal table program, and unfortunately I was having a little trouble with this, so we'll get to it. But what I wanted to do now, this was my issue, was trying to figure out how to share PyCharm with you in real time. And I'm working on that. So let's see. All right. Let's see what we can do here. We may have to end early. Let me, before I go the one thing I do want to do is talk about homework 5. So before I go to homework 5, does anybody have any specific questions? Andrew, thanks for the question. Yes. Is screen share an option? I haven't figured out how to work it. It's the option it's giving me is share multimedia. Let's try share my meeting window. Okay. All right. How was that? Did that change for anybody? Okay. All right. Let's see. Okay. Let me go to Pie chart. Sorry, that was one of the dogs. Oh, cool. Let's see. Which file did I want? Okay. I wanted the other one. That's the one I wanted. Okay. All right. Let me go back to sharing to PyCharm then. I was confirming that it worked. Okay. So what we've got here is code that, if you recall, opens files with had a metal table in it. In this case, I'm just using a text file. I could do it with a CSV file. Let's do it with the CSV file for now.
It's not showing.
I'm sorry, what was that?
It's not showing.
It's not showing now. Okay, that's a bummer. I thought I had it. Okay. All right. Okay, when it says I'm sharing my meeting window, what are you seeing right now?
Just the meeting window.
Just the but so when I change the window that's on top, you're not seeing PyCharm.
Oh, that is correct. I'm not seeing PyCharm.
Okay, bummer. All right.
Did you press on the orange thing? You're sharing your meeting window. Is there another option there? Like under share, maybe? Under. You also muted yourself, by the way.
Thank you. Sorry about that. I did not realize I muted myself. How long ago did I do that?
20 seconds, maybe?
Oh, good, good. You said 20 minutes ago I was going to be very unhappy. I'm not happy, but I would be very unhappy with that one. Okay, so yeah, like I said, for whatever reason, the share content is grayed out. Hang on. I've got 3 other computers sitting next to me on the desk. Let's see if I can Google that one real quick. Okay. Oh, great. It's a known bug. It's a bug. They're working on it. Let's see. So, can I get a new? Give me a new page. Here's what we're going to do. Rather than working directly in PyCharm,
You are gray again.
right. I'm just getting something. Oh, great. It won't let me copy to this page either. All right. So, note for the future, I'm going to have to get the code ahead of time. Hang on just a second. What file is this called? This is called code March 4th coding. Okay, got it. we're going to open the file directly. I just have to find the doggone. Okay, we're going to bring in the metals.txt file that we started with, and we're going to try to write the code on the fly, and I will confirm that it works as we go along. Sorry for the gray. I knew I just wanted to go and make sure. Problem is it's not letting me. Okay, WebEx for some reason by default will not allow me to open a .py file. I'm going to have to note that. Okay, it also doesn't appear to want to let me edit it in real time. All right, so this is a regular first-class disaster. I'm going to do this one way or the other. Hang on with me for just a second. Save this as, and I'm going to remove the .py from the name. Okay. That's a pain in the neck. All right. And let's see. Zoom this sucker. All right. So this is our original code. We're open two files, the one we're going to read from and the one we're going to write to. For this example, these are different files. I'm going to try one more real quick, Google. Nah, I'm going to have to work on that one. Nope, it doesn't give me any easy way to edit a file as I'm actually doing this. So we're going to have that done by Wednesday. Okay, so at any rate, now that I know this, I will be able to pull up my the file you're going to work on in Lab 6. The basic point here, I can't seem to edit it in real time on this. I will have that fixed by Wednesday. We're going to open the two files, the one we're going to read from and the one we're going to write to. For this example, these are two different files. So what we have right here is this with open as metal file. We would have this as a function. So I would start with def read a file, and a parameter would be a file name, and then I would just read it in and read it. Remember that a read line statement reads in one line. So I would read in the headers from my metal table as a line, and I would be able to do something with that. In this case, I'm just going to put the same header line back out in my output file. Then I would have a column called, I want to add a column called total, because if you recall in this, the original data I had, I didn't bring in the total number of medals won by each country. I just read in the country name and the gold, silvers, and bronze. So I added something to the header line to put in a column heading of total. Now, that would all be one function, and then I'm done. That function is going to return just a simple thing, a string that says, here's your data. Now I'm going to have another function that's going to process the data, and so this is another module that will read it, that has the lines of data, that converts the number of golds won to an integer, converts the number of silvers won to an integer, converts the number of bronzes won to an integer, stores that in an integer called total, converts total back to a string for output to a file, and then appends it to the string that we read in. So this would be a separate function that we would be, and I will have a finished example of this for you out on the website, out on GitHub, of exactly what this function would look like. And then we would have another function that would write the file. Okay, so since I know what I have to do, a better example of this is actually one in the lab. Wix. I just need to file. It's called Lab 6. I go. Name that sucker. Lab 6. Okay. Now go back to Wix. Okay. Give me a minute. Here we go. All right. So this might be a better illustration. This is what your lab assignment is. So you can see I start, since Python programs don't have to have a header name or anything like that, I start with a header comment that's in between the sets of 3 double quotes. File, replace file name.py with your file name. Author, your name, date, today's date, the day you do this, your section number, your UMBC email address, and a description of what the program does. So if we go to the main program is down here. It starts with if underscore name underscore equals underscore main underscore. So this is where the main program starts. I have a list, which I call physicists. It contains the names of a number of famous physicists: Albert Einstein, Arthur Compton, Enrico Fermi, Niels Bohr, Werner Heisenberg, and Ernst Schrödinger. Now, what I want to do is figure out how many letters are totally there in all these names of all these physicists. So I've given you some functions because I need modules to do this. Now, the first thing is I've got a function called getStringLengths. So you have to write code that calls getStringLengths and passes this list of strings called physicists to this function. I tell you in the function heading that this function gets the lengths of each string in a list. The parameter, this input strings, is just a list of strings, and what I'm going to return is a list of integers containing the lengths of each physicist's name. So I would have a list that returns, how many letters are in Einstein, how many letters are in Compton, and so on. So I'm going to take in this one parameter of a list of strings. I'm going to convert this, or I'm going to find the length of each string and put those into a list, and I'm going to have a return that the return statement is just going to pass back this list of integers. Now, that's the first part. So now you've got that. I need to finish determining how many letters there are totally. So now I need a call to sum a list. Now, these are, this is to show you how this works. These are fairly simple and very small functions, but this is an example of how you would break the program into these various pieces. Okay. So after I got the string lengths, I would call sum a list. I pass in a list of integers, and it just sums them all up, and I would return the sum of the list of integers. So once I've done that with physicists, I call the list of, I call the get string lengths to give me a list of integers, telling me how many letters there are. Then I call sum a list that sums all the integers I had, and now I just print out a statement on the screen for the user that says print out the number of letters with appropriate descriptive text of how many letters there are in this data structure physicists, in this list of physicists. So you print out something that's said along the lines of, there is a total of this many letters in physicists, okay? So now I give you the names of some famous chemists, Marie Curie, Wilhelm Röntgen, Linus Pauling, Ernest Rutherford, and Irene Joliot-Curie, the daughter of Marie Curie. It's the same thing. It's a list of strings. And so what you're going to do here is write the same function calls, call get string lengths to get a list of integers, call sum a list to get the sum of all those integers, and then print out something that says, here's how many letters there are in the list of chemists. Now, when we talk about this being a modular program, the important thing is, if we go up here, and I apologize if scrolling up and down fast makes people busy, I'm trying not to do that. The point is that even though this sum a list is a fairly simple module, it's only a few lines of code, it's something we do twice. So why bother writing it twice in the main program, or why rely on a loop in the main program? Just write it as a function, make it a module, put it over there, and then you don't have to worry about it. You just call it. The same thing with get string lengths. Get string lengths, you have to figure out how many letters are in each string in a list of strings, go for it, make it a function. So when we modularize this program, it's a fairly simple thing, but it gives you practice at, here's a data structure, call a function, call another function, print out your answer. Here's a separate data structure, call a function, print out your answer. So this is an example of modular code because we broke it up into functions that would let us do something repeatedly with different data. Now, what we want you to do in the last part of the lab is...
Wait, hello?
I'm sorry, go ahead. Did somebody say something? Oh, somebody posted if I stop sharing the meeting window, we will see the page bigger. Thank you. Let's see. How's that? Good, bad, indifferent?
It's good.
Thank you. Okay. So let's go over and also I can probably make that panel a lot bigger, I think.
I do, good afternoon. I do have a question as well.
Certainly, go right ahead.
So the
the parameter is always going to be the argument of a function. Like for definition, sum a list, the argument is numbers,
Okay.
and the parameter is integers. Is that how you would?
Well, the way it works is the parameter is the thing in the function definition. So if you can see the lab assignment now, def sum a list parentheses numbers. Numbers is the parameter. The argument is the thing in the main program that maps to that. So you will have something in your main program that says sum a list parentheses lengths or whatever. Lengths is the argument. The thing in the main program is the argument, and the thing in the function definition is the parameter. Does that help?
Okay. A little bit. And another question.
Yep, go right ahead.
For good coding standards, is it better to have, or does it look better to have more functions in the beginning so that you have a short, after your if main underscore equals name, then you have your code on the bottom? It would be like more,
yes,
that's shorter, and then on top you have like a lot more functions than you would hardcore code.
Right. Yeah. Really good question. Really good question. The answer is yes. As you get more and more advanced in programming, the main program should be very short. The main program is typically going to be only something that calls functions. It's going to maybe do an initial setup and then a function call, and that's it. So your main program should be as short as you could possibly get
it. Okay.
Okay?
Mm-hmm. Thank you.
No problem.
Briefly, in terms of, like, I understand, like, input, it's
right.
Whatever we input define it as. So if we call that a variable numbers, we can do sum a list, parenthesis, numbers, close parenthesis. Would it be good practice, but when it outputs as a variable as defined within the function, correct?
Correct.
So we would, like, I don't see here in Lab 6 that it defines what the output is what the variable the output is. Would it be good practice to write what that variable is? Then if we want to use that variable later on in the result of the next function, in the argument of the next function.
Okay. Yeah, if I understand your question right, yeah, that's a good habit to get into. The actual code that you would write here is going to be something like, you would have a variable like, say, total length. And so your actual function call would be something like total length equals sum a list parentheses numbers. And so that way, when sum a list finishes and gives you an answer in sum a list, you'll have a return statement, return length, return whatever. Okay, that will go directly into your variable, the main program, total length. And so then it becomes very, straightforward, very obvious what you've got in terms of, this is the answer I got from my function, and now I can pass it directly to the next function to do the next thing I need to do. So is that the question you were asking, or did I get something wrong?
Approximately right, but thank you.
Okay. All right, so the last part of the lab, again, we've given you two things. We've given you a list of physicists. We've given you a list of chemists. The last part of the lab is you have to write a function that prompts the user for names. And so we've called that function getNames. And so we have the def getNames. You have to figure out, the way I've structured it, it does not take a parameter. You have to figure out what you want to do here. Obviously, you have to prompt the user to enter a list of names. You have to put that in a while loop, and the reason it's a while loop is because you're going to use a Boolean flag to stop it, right? Please enter names, enter Q to stop, or enter 1 to stop, or something like that, your choice, right? And so your getNames function will prompt the user for names and then go into a while loop, and then will continue until the user hits some magic value like a Q or whatever to stop. And then it will return that list of strings. And so that all that function does is it's it's a little bit longer than the others because you need the code for the while loop. You need the priming, read, prompt the user, read in the first value, and then enter your while loop and say keep going until, while input is not Q or something like that. That's what that code will look like. And so that'll be what that function looks like when you write that. Now, once you've done that, the rest of it works the same, okay? Just like you called the function get string lengths and sum a list for physicists and chemists, you're now going to call those same functions using the data the user just entered. So you have to have some name for that list. You have that list, you pass it, and then you print out the same result. So in a sense, this program is modular because we've isolated, get string lengths gets used a bunch of times, so we don't bother rewriting the code. Sum a list gets called a number of times, so we don't bother rewriting that code. We just call the function. And get names is an independent thing. It's something that's done separately, so you can make that a separate function. And then your main program is actually fairly short. Really, the only two things that take up space in the main program are the me defining the list physicists, defining the list chemists. Okay. So this is an example of what we mean by modularity. And as I said, Lab 6 is really structured just to give you some fairly straightforward practice with how it works and where the code is and how to match up your arguments and your functions. Because if you've looked at Project 1 yet, you'll see that there is a ton of that in Project 1. There's a bunch of different functions that you're going to have to write, and you're going to have to match all the arguments and functions to that. As I said, really, Project 1, the main purposes are using functions and reading from and writing to files. If you can do functions and read and write files, Project 1, you've got 80% of it done. Okay. It's all about modularity and how to do this. Okay.
Quick question.
Sure, go right ahead.
I thought functions, when you return a function, it erases, after it returns, it erases all that stored memory. That's
correct. That is, okay, the scope, that gets back to scope. What happens is that Python creates a separate area in memory for all the variables used in the function. And then, when the function is ended, when the function terminates, all of that is erased. So you can no longer get to those variables. However, that's why a return statement is important. The specific variable you mention, you name in the return statement, that one value is copied back. So you don't lose the value you return, you lose everything else. Okay, and that's why a return is key, because you are exactly correct in that when the function terminates, all the memory of the function is gone. But you do bring back that one value you have in the return statement, or that one list of values in the case.
Okay. Thank you.
No problem. And I did mention last time, in case anybody forgot, it's been spring break or a lot has happened, Python does support returning multiple values. However, in this class, we only permit one return. Now, you can return a list. So it's fair to say I'm returning one thing. That one thing happens to be a list, as in my get string lengths function up there. But in this class, you can only return one thing from a function, although I think I gave an example last class meeting. Python does permit it. It's just a complex function that's easy to get wrong, and so we say for this class, no. If you need to do it, make a list and return a one list. Okay? All right. That was the material I had planned for today. I had deliberately made this short because A, I wanted to talk about modularity, and B, I knew I was going to have to do a lot of administrative stuff talking about the homework, the lab, and Project 1. I will have a couple of these bugs figured out and make sure I have the current versions of everything next time, so we'll have this hopefully be able to share content more. Does anyone have any other questions? Oh, the one other thing I did mention is I did want to make sure. I know some of you who've already used it. I also set up a Slack channel for this section for asynchronous. If you have questions or comments or whatever, feel free to fire them into the Slack channel at any time. And I try to read that several times a day. And plus, I get notified when somebody posts something to it. Anna and Jordan do have access to the Slack channel, but they will largely be paying more attention to Discord because the department put all the TAs on Discord, and that's easier for them. But you can use the Slack. A number of you already have. Feel free to, we can do that, and I do check Slack regularly. That's being said, anything else? Any questions? All right. Thank you for your attention. I appreciate everybody showing up. As I said, I know this is not ideal. I have taken online courses. It's not the greatest, but we have what we have, and we'll do what we can do from here on. Feel free to ping me if you need anything, Slack, email, whatever. And I will, if not before then, meet up with you on Wednesday at 4 o'clock. So thank you, everyone.
Thank you.
Thank you.
Thank you.
All right.